Good day, everyone. Welcome to our webinar. We have a session. If our CTO talking about one. So I'd like to get coming up here, but first let me take care of some housekeeping items. We are recording the webinar, so everyone will get a email following the webinar with a link to the recording. We have some handouts also that we'll be attaching to that email. You can also find those in the handout section of the interface that we're using for the webinar today. So we love questions. We're going to be talking about a lot of great things around containers and container security and cloud native security. And so we'd love to have your questions. So please type those into the Q&A section of the interface on your browser. You can also type them into chat. We'll be monitoring both of those and do our best to get to those. So let's move on to our topic, Devsecops Predictions for 2021. I have a great pleasure of introducing my fellow panelists here for the Fireside Chat. And by the way, my virtual Fireside Chat, I have my two dogs here, Eddie and Finn. So, you know, if we get a delivery, I may get a bark or two. So hang on for that. Hopefully that doesn't happen. But great to introduce you to our two panelists that are joining me today. First is Brian Fox. Brian is CTO with Sonatype. And we also have Fei Huang, who's co-founder and CSO with NeuVector. And a little bit about myself. I'm Mitch Ashley. I'm founder and CEO of Accelerated Strategies Group, a analyst firm focusing on security and container cloud native applications. So welcome, gentlemen. Good to be here with you.
Thanks for having me.
Absolutely. How about let's start with just a bit of introductions. Brian, would you introduce yourself? Tell us a little bit about you. Tell us a little bit about Sonatype for folks that may not know much about Sonatype yet.
Sure. My name is Brian Fox. I'm one of the co-founders and CTO at Sonatype. My background is in open source development in Java, specifically Apache Maven, for many years, 16, 17, lost track. And Sonatype, we're about helping people secure their software supply chains and helping developers make better choices so they can leverage the open source and innovate faster.
Excellent. Fei, why don't you introduce yourself?
Sure. My name is Fei Huang. I'm a co-founder and the chief strategy officer of NeuVector. NeuVector is one of the earliest, container security solution vendor in the market, and basically we were mainly selling to DevOps, Devsecops, and security group for the container Kubernetes security solutions. And yeah, that's a quick introduction here.
Great, spot on for our topic today. Well, let's jump into some conversation about a few things. I know in September, I believe, of last year, both of your respective companies announced a strategic partnership, and I'm very curious about that. Now that you've been working together a little bit together for a while, tell us a little bit about what the partnership is and why you decided to work together. What's sort of the better together strategy? Fei, do you want to start?
Sure. Actually, it's coming from the market and the customers. I remember a couple months ago, right? And NeuVector have quite a lot of enterprise customers, and we were protecting their production environment of the first Kubernetes deployment, and also at the same time, customers using Sonatype for the build time security. So it's interesting that the customer using both products and they start to get used to it. Then they realize, hey, why not? I can connect those two together, right? They want to have a single glass of pane to manage the security for their applications. Doesn't matter, right? It's a build time or like staging of production. So that's how the conversation starts. And when the feedback go back to the team, we feel this is really an interesting point and makes big sense. So that's how we started rolling.
It's always nice to start with the customer. I have a good reason to be working together, and bumping into each other in customer accounts is also a good indicator that maybe some opportunity to work together. Maybe tell us a little bit more about, so what is it that you do together that maybe the customer now doesn't have to do because you do it for them, or new capabilities, whatever that might be?
Yeah, I can maybe add some highlights on that. Is because like for example, NeuVector was before NeuVector was focusing on the pipeline security, which means you're gonna have to have a container first, then you put that container in the pipeline, do the CI/CD, right, deployment and testing, go to production. That's why NeuVector have a lot of functions to protect your environment. But there's another big piece of that is basically the upstream story, which is, for example, if you see a new vulnerability being found, right, you want to prevent that from happening at the beginning when you want to build the container. That's something, I mean, out of reach of NeuVector current solution can do, which Sonatype is the best approach on that side. So think about put those two solutions together, then you can have the build time. You can have remove all the possible like vulnerables, like as early as possible, so your developers don't put malicious codes into the images. And then how about those existed, let's see, applications or existing containers that's already running? That's the NeuVector where we can protect, right? Anything malicious happens, we're gonna block that bad behavior, and then we can feedback that back to the upstream. So the upstream, downstream story put together for customers, it means continuously monitoring security, continuously compliance, right? So that's the high level kind of story for the why we solution should work together.
Okay, great. How about Brian? How about your perspective? How about the Sonatype view of the relationship?
Yeah. So, what we've been building at Sonatype, one could consider a developer-first control plane for managing many different aspects of information about the code you write and the code you borrow open source, right? And so early capabilities that were demanded by the market was license analysis of the dependencies. What's the open source license? Then came, attention on the security aspect of it, right, which the industry now calls SCA. And so we've been doing that since 2010, and trying to find ways to allow organizations to intelligently manage risk, but to do so in a way that is really compatible with development. Allow lists, deny lists, those don't scale. And people are kidding themselves if they think they're actually managing their development that way. The developers just work around it, right? So we've built a system that allows you to basically set the guardrails around what's okay, what's not okay, and then provide the data and the automation to allow the system to, inform the developer, hey, this choice you're about to make is not good. It violates, one or more of these corporate policies. But this other one here is awesome. Maybe you should do that. And so when you look at that, there are multiple dimensions to this. And when you start developing on containers, the layers and containers you're pulling in are every much components and dependencies as the jars and Python pieces that you're doing. And so it's natural for people to say, what about the stuff underneath my application? Historically, we've been very focused on the application itself, but the containers beg for going deeper. And so we implemented different pieces in the past, but what we observed is that the container space is almost a whole nother business, right? It's another wheelhouse to do it really well. And so we had been kind of working against this tension where some of our customers just wanted a simple thing, and we realized actually the simple thing will only get you the first week. After that, you're going to realize that you actually need far more than just SCA of the container layer itself. If you're actually doing containers and you actually care to do it right, you're going to care about things like, do I have the wrong ports open? Are the systems talking to places they're not supposed to be? Am I running as root? The operational aspects of the container that are every bit as important from a security dimension, but are a different wheelhouse. And so that's where NeuVector comes in, and the depth of the solution kind of allows our customers to have their cake and eat it too, right? That they can get the the results into the control plane that we provide with the policy, highlighting what's important, even blocking releases and promotion, doing continuous monitoring for when things are found after you ship. You can get all of that stuff, but you can get it at the ultimate depth that that is really required via the NeuVector technology, right? That's why it's better together, because both problems are sufficiently complicated that a one-size-fits-all solution, doesn't always cover all the things that you might realize you want later.
Mm-hmm. I really like what you said too at the beginning about sort of the old techniques of walling things off. Sort of goes against the whole contemporary software architecture of cloud native and containers and how we do things today, and distributed running across all kinds of environments, distributed development, distributed testing, kind of everything. So it seems like those some of those challenges in those complex environments would be an area where you both fit well together working with customers. Would you agree with that, Fei?
Yes, yeah, that's definitely the. I mean, it's driven by the customers. I think it's the perfect fit here, and we have our expertise on the production security side, especially network security for the containers. And the Sonatype has strong experiences on the build time security for developers. And also, I see an interesting trend in the past few years, right? This is a fast-growing market, fast-growing technology. Also, it's changing fast, right? Like, I mean, in some of the organizations, it's not clear who owns security, because it's have both the developer side, the security, the pipeline, the production. It's basically end to end from all the way, right? You're gonna have to have some security. Then it's not a legacy traditional security role. You only care about the production. You only care about the firewalls or endpoint security. So it's not the same foundation now. That's why I think we need to work together to solve the solution for the customers, and it has to be covered, right, the whole application lifecycle.
Yeah, very good. Let me just interject to our audience too. Feel free, be sure and enter any questions that you have. You can put them in the Q&A section. You can also put them in the public chat. Happy to get to those as we're moving through our conversation. Also want to mention there's 2 handouts, and I'll get to what they are in a little bit here, but you can find some really good handouts in the handout section, or files you can download, some PDFs, some great information. So kind of do a little audible here. Let's talk about DevSecOps and the whole move to shifting left, and how that's really happening within organizations, as you were talking about that, Fei. It's a popular topic. You hear a lot about DevSecOps and shifting left. There isn't kind of one definition of it. I'm really curious about sort of how you seeing customers implementing shift left in their strategies, and what are some of the interesting things you might be seeing from that. Brian, do you want to take a shot at that?
Yeah, sure. When we started solving for this problem in 2010, 2011, the IDE was mostly as far left as the tooling went. In the decade since, GitHub and GitHub-like things where you can submit pull requests, that's the campfire now. That's where the first place where people can get feedback really is, at least in a systemic way. Because you can argue further left of that is where developers are choosing what to pull in, but in many cases, that's the result of Google. There is no tool that they go to and use that helps them make that front choice. So the soonest you can catch it is when they're building it or when they've submitted the pull request. And that's where we've seen a lot of the focus of late, and trying to get real-time feedback on my pull requests as part of the code flow, right? And it's a natural thing. It's where your unit test feedback and integration test feedback is pushed these days as well. And so, a lot of our attention has been on trying to provide that type of feedback as early on in the infrastructure, and it's important to be able to do that as well, because a lot of the supply chain attacks that we've seen of late are targeting the development environment themselves. So if you're gearing up to protect yourself before you release something, that's not where today's war is. Today's war is in your development house. So if you only release every 2 weeks, that's potentially 2 weeks that something's going on inside of development that you don't realize is happening. And so moving it as far left as you can, and that includes being able to understand, obviously, the container aspect of this as well, because I mean, you're downloading code and you're executing it, not just at an app level, but at an operating system level, which opens the doors even wider. And trying to put your arms around that in a real-time way, I think that's where NeuVector is unique in the ability to really understand the network traffic as well, so that they can catch things that are fishy in one of those containers, even if it's just in development and hasn't shipped, right? So I think that's kind of where the battle is happening right now.
Yeah, it's interesting. I'm glad you brought that up. This is a predictions fireside chat. So one of the predictions that I've made previously, but it was in 2021, is this whole issue of inside the development process, because that's really, I mean, the supply chain part of it we all heard about, of with distributing software to customers and getting into their networks and that whole business with what happened. But really at the core of it, they got into the software creation process, the build process. And that really, I think this year will be the year of, we're really going to examine the tool chain and the security of it, and how do we detect whether it's when it's happening or something that might get into test as well, that kind of thing. So I think we're going to see a lot more attention to that. Fei, do you have any thoughts about the whole shift left? And
yes,
you're seeing in market?
As we do, actually, that's a good point. Brian mentioned about the supply chain attack, which happened recently. Actually, I think the SolarWinds, right? That's also another example of you can show you it's a sophisticated attack, right? It's getting to the supply chain at the beginning by hijacking your DNS or patch or releases. Once it gets in, right? I mean, of course, you can have first line of defense is at the build time, which is shifting left. You can really do a carefully control your libraries, licenses, right, open sources at that time. But there are also chances. I would say shift left is super important. It's really nice, practical. You're gonna have to have. Also, there are some already existing applications. They may already have something built in containers, right? It's buried inside of the image for a long, long time, which people may not be able to catch at the beginning. They're going to flow into the pipeline, go to your production environment, and it's going to run in there. Then it become like an insider attack, insider threats, right, later on. So we see a lot of cases like that. Just one quick example is, I remember we see a lot of customers in the past 2 years, they were facing, some kind of a crypto mining issues, right? Which is actually some open source libraries, right? I'm not blaming open source libraries, but sometimes some people are going to put some malicious code inside, and when it gets built, because the binary totally changed, there's no signature can match that. It's going to flow into the production. That is like a time bomb, right? It's going to launch some crypto miners later on at a certain condition. It will start maybe stealing your IP information, or maybe even just silently do the mining thing for like Tesla is another case, right? This happens a lot. I think a leverage is more infrastructure, because everything happens so smoothly with automation. It just drop into the pipeline. If you cannot find it, it just quickly. It start to do the bad things. For those type of attacks and threats, I think we see the customer do need a tool on the right-hand side as well to detect, right, to monitor continuously. For example, I have a customer, I think a year ago, right, they deploy a MongoDB database container in production environment, which is actually a slightly modified MongoDB, because their developer add some wrapper library, wrapper applications on top. It's built on top of MongoDB container. And after deployed, everything looks so good. But, NeuVector actually detect some malicious connections, go from this container all the way to outside. which is this is supposed to be internal, right? A database, it should not talk to an external at all, but it happens. And luckily, NeuVector captured that traffic. They did a deep analysis, realized, hey, this is one of the open source library. They're doing like a weekly or monthly health check, connecting back to some external servers. But the company's security policy doesn't allow that. The issue here is nobody knows that, only when it happens, once a month or once 2 weeks. So you do need some kind of a tool to be able to monitor real-time network traffic at the production site or at staging testing stage, right? So that's one example, like the tool like NeuVector can help, because we detect all the behaviors at the runtime. We do deep traffic analysis for you on the fly, which really give you a deep visibility on that. And as I just mentioned, those kind of behavior, malicious behavior, is super hard to catch at the build time. You can try to prevent all the kind of known issues, do all the checks, but still, right, something may happen at the runtime as well. So my really suggestion is you want to put the protection for both sides, right? And it just you cannot lose any of the security on any of the kill chain checkpoints. So that's kind of interesting cases I would like to share. Yeah.
Mm-hmm. Yeah. Mitch, there's a really great question here that might be timely to answer. Mike is asking, isn't the problem that you talk about shift left strategy, that the malware have implemented it all the way up into the supply chain? And yeah, that's happening. It happened this week with a large disclosure where somebody exploited sort of an endemic issue in the NPM ecosystem and collected a lot of bounties. Fortunately, he was a white hat. I guarantee you that copycats are doing this right now. How do I know that? Because it happens every time, right? And to kind of counter those kinds of things, we've been building capabilities as well to basically do behavioral analysis of the open source projects themselves and the committers and the dependencies they use, so that we can detect in near real time when a new release appears in the repository, whether it appears to be normal or not. And the only way you can do that is with MLAI techniques to understand patterns that humans can't do. And it's proving to be really effective. We found, it seems like every week we've been trapping things since we put it online in October, new malware that's been published. And the one that was announced earlier this week, actually we saw those happening in real time all summer long, but had talked to the researcher and understood that he was a white hat and that there was a coordinated disclosure going on. So we worked with them on that. But customers using our platform would have been alerted that these components they shouldn't be using, right? And so that's what you have to do. And the mental model I use to explain to people is credit cards, right? And when you swipe your credit card, the credit card company is always looking for fraud. And in the old days, it used to be books that they would ship out quarterly with numbers that were known to be stolen, right? But that's not sufficient anymore. Now they do it in real time while you're still standing at the register. Well, how do they do that? They understand your consumer behaviors, what's normal for you, or at least a stereotype of you, and then can decide, is this typical? So if my credit card is swiped, pretty much anywhere in the world pre-pandemic, that would be normal because I traveled a lot. My mother's credit card, same thing. No, that would get blocked probably instantly, right? Why is that? Is because they did that behavioral analysis. That's what we're doing on the components. So we understand that these developers have never released from this part of the world, or they've added a dependency that nobody else is using, and this is a really popular project. Popular projects tend not to do those kinds of things, right? That's how you counter the early malware, because the attackers are crafty. And yes, there are copycats, but there are always novel ones too. And so how do you figure that out? That's what we're trying to solve for.
Yeah, copycats, that always happens, as you mentioned, right? Any parts of that supply chain attack that we're talking about with SolarWinds. Good. Well, you know what? We were talking about containers a little bit ago. everyone is working on how their architectures and how they start to build applications and cloud native, containerized microservices technologies. So it's certainly not something new, but it's certainly growing fast. A lot of organizations that are happening, developing with container technology, Kubernetes, et cetera. What are some of how would you describe the state of container security today? I think it's one of those, the pattern always happens. We have a new technology. We all go about our way of, getting on board with it and starting to use it. And then we ask questions about security and operations and other things. We're kind of at that state now, I think, with container security. Brian, do you want to take a shot at that?
Yeah, I mean, I think we're going to see a natural evolution of what's going on, right now, attempting to detect the behaviors earlier, the unusual behaviors that are happening. I think, being able to figure out namespace issues like the malware that I was talking about earlier, those kinds of things can affect the container layers as well. So I think the future is a lot about trying to predict things that are not known. If you look back at what's been happening, the biggest challenge, certainly when we started down this general path, is projects would get 0-day responsible disclosures. They would fix them, they would release them, they would scream from the mountaintop, and then weeks later, users would still be affected. Why? Because they didn't know about it. I think we've gotten, and frankly, that was the first part of the problem we set out to solve, like closing that communication gap. And I think generally the industry has moved in that direction, so the response times tend to be a lot faster. But when it's new and novel, we've seen some of these malwares can be out there for 6 months before the community realizes it, right? And then, of course, it's treated like a 0-day and a responsible disclosure, but all that time has passed. And so, trying to, it's a bit like antivirus. Antivirus tools were really good once somebody had identified the virus and could put the fingerprint in, then everybody knew about it, right? But then they had to start changing their behavior too, to look for, polymorphic kind of things and fingerprints, and then behavioral analysis to detect virus-like behaviors. And I think that's where we're at now in dealing with this type of stuff. I mean, frankly, what I was just describing, we're trying to do for malware is effectively that. What NeuVector is doing on the network layer, same thing. So I think it's going to be a continuation of those types of behaviors as we look forward.
Very good. Fei, you wear your strategy hat in your role as CSO. Kind of what you're thinking around what's on the horizon for containers over the next 12 plus months.
Yeah, I mean, one thing I like to double on what Brian said, right? This behavior detection is super critical and important. People start to understand that more because, in the past more than 10, 20 years in the security industry, as Brian said, everybody chasing for signatures. Like I have 1,000 signatures, I have 10,000 signatures. It's like an endless chasing game, right? It doesn't really help for the container, especially this distributed environment, because it's just such a scalable environment. You cannot, get that protected in time. So that's why, I mean, the company like NeuVector, Sonatype, we have those very similar concepts. If you think about the behavior detection, which is NeuVector doing on the network security side, this is our innovation there. You're gonna try to understand the container behavior. That anything malicious, right, behavior, and this is different from the baseline behavior, should be triggered alarm and should be investigated. That's definitely one thing I think is happening already. I'm happy to see more and more customers fully understand that. I think that's really the best approach for the environment. And another thing I want to mention is really about the automation. I'm myself super excited because just one quick example, like 10 years ago when we want to have a new release of product, we want to upgrade. It takes me a long time to prepare for that. I'm gonna have to really carefully shut down my service for a couple of days or even a couple of weeks for big data center. And today in the Kubernetes world, you upgrade to a new release, it's like minutes, right? Or even seconds for some like a simple pods deployment. This is a rolling upgrade. So I want to talk about that because same thing gonna happen for the security solutions. You don't want a security solution to slow down your operation, include upgrading, management, or even any of the maintenance. So security solution needs to be cloud native and Kubernetes native. So you want to be able to do the same thing, rolling upgrade for your security solutions, right? And also CI/CD pipeline automation is part of that, right? For example, you want to be able to kick off a build all the way automated to testing, staging, production. Then you cannot ask a security group, hey guys, stop, check these things for me before I can go production. That just, it's not, it's still a lot of companies doing that, but that's not the best way to do this. Mm-hmm. Right now, actually, because NeuVector is a Kubernetes native solution, you were able to do the full security automation in the pipeline. You don't need to worry about, did I need to check something, configure something, right? So you may think, oh, this is a firewall, this is going to be complicated. How can I manage policies? Actually, those issues was taken care of by the security automation already, right? The solution will be able to, automatically fit into the environment, fit into the pipeline, then build the policies for you, right? So it's gonna just flow into the stream. What you need to do is just go check, then see, okay, go, button click. You should have your application, running, and at the same time you have the policy security in place. That's, I think, a big change, compared to like the last several years. More and more people are going this way. We have some customers, I think it's a big insurance company. They actually was a pioneer of that kind of practice. They actually build everything fully automated. You don't need any kind of manual operations in between. They can have an application release, right? Same time, security policies, security policies code, go to the pipeline, go to the GitHub as well. Then, kick off the Jenkins task and all the way to go production. Then they just sit and wait for all the feedbacks and alerts, dealing with the incidents. So that's really amazing automation. I see it's fairly large enterprise, right? They can achieve 100% secure automation. So that's, I think, one thing I see. It's a really a really nice future growth here. Yeah.
It definitely, that we follow the model of automate everything. I think one of the things that we've learned with software is when you combine that with increased velocity, then those linear or those manual processes also need to fit into that automation, because a human couldn't check it fast enough or often enough, or keep up with the changes that are happening. I want to point out a couple of resources. If you go to the handouts tab in our interface here, there's a really good document, a NeuVector document on automating container security into the CI/CD pipeline. There's a great Sonatype Nexus lifecycle, so check that out. And last but not least, we've got a really good paper on Kubernetes security. So some great resources. You can download them there. We'll attach it to our email we'll send to everybody. So speaking of Kubernetes security, let's turn our attention to kind of what have we learned? What are some of the best practices for container security? Because we've been doing this for a while. And of course, we're learning new things that we need to do. But maybe Brian, could you talk about sort of the essentials or best practices for secure development using containers?
Sure. I think it starts with any of your other dependencies, understanding the dependencies all the way down to the container. So knowing who produced that container, what's inside it, why do we have it, trying to make sure that you get them from a trusted source, limit the number of versions you have, all the practices that make sense for general dependencies apply to the containers as well. Some of the challenges we see some companies is, they end up with development starting on one set of containers and then trying to move to a blessed set of golden images, late in the process. that's certainly a way to harden things, but it can be really disruptive to development. And we see, especially when people are pushing the cloud, a lot of times that's ineffective because development will just push their thing anyway via their own system. So I think those are some of the challenges. Fei, I think you're even closer to some of those things. So I'll let you respond.
Yeah, I mean, actually, yeah, I think, yeah, you're right. I mean, if you follow this from like a build, ship, run, like the chain story, at build time, you definitely need to do a lot of checks. Make sure your tools picking the right libraries, right? Pick the cleanest or the best possible, libraries and packages to build your application. Of course, you can have some even source code, sanity checks, etc. That is really good practice in place. And if you look at the after container gets built, right, you're typically going to go to your registry, container registry or repository. That's actually one first checkpoint you can check as well, right? You can connect the tools like NeuVector have. You can connect to the registry, do like automatically scanning images, make sure all the layers, right, are good in good shape, right? Any new CVEs came out, you're going to immediately trigger the scan. You need to know, hey, what are the risks I should pay attention to or fix if I could. So that's the I would say the registry time. Now, if you look at the next step, gonna be maybe in your staging environment, right? Maybe you want to check your this is very close to production. You want to check your environment because container is just one part of application. The supporting foundation is infrastructure is more than that. You're going to have operating systems. You're going to have networking below that. You're going to have storage below that, right? You need to make sure for example, your RBAC, right? Your roles are setting correctly. Not everybody should be able to modify or change anything, right? The container should be run as read-only by default, right? Like your Kubernetes API service port needs to be secured, hardened. This is a very famous man-in-the-middle service attack. That's basically, if you use default version of Kubernetes or OpenShift, you're going to have a big trouble on that because that's a design flaw. It's not even, I would say, a bug or something. It's just a design flaw that if you didn't accidentally use the default setting, then your API service is going to be exposed to all the cluster. Then very easy, your traffic going to be hijacked by a malicious container, right? So that type of thing happens recently. And so I will talk about it's a full stack security. You want to not only care about the container, you also want to care about the configurations, security access rights, right? All the layer down. You want to make sure your networking, right, plugin is a good one. For example, if you use a service mesh, right? How does that service mesh configured? Does that service mesh enable the encryption or not? This is a lot of points you want to check. So the security tool is going to help you do the CIS benchmark checking. So make sure all the basic, maybe 100 items of security checks are good, are in place. Then you move further. You want to go ready to deploy. You want to have a good admission control in place, which is really the last gate before you go production, right? If you have anything wrong here, you have a last check here. Make sure only certified images can be deployed in production, because container came from multiple sources, can came from GitHub, right? Can came from your Docker Hub or your internal built applications. Then you want to have some places to make sure, okay, only verified, certified container image should go production, right? That's the last gate. Now, of course, when you go production, now it becomes a runtime thing, right? Then your container service is going to be publicly facing. It's going to talking to external all the time, and you may lose of control a lot of things. But at the same time, you do want to have a security control around that. What if people are doing port scanning, are doing like DNS hijacking, right? Trying to do like a layer 7 sophisticated attack, like those crypto mining attack, like a DNS tunneling attack, right? Those or even DDoS flooding. All those attacks can address at the runtime. So that's basically I'm follow this build, ship, run the chain. You want to look at the multiple points to have a security in place. And a good security tool can help you to, as I said, automate that. Can also help you to evaluate every stages. So last thing I want to add is really this continuous compliance concept. So compliance checks are required, actually a hard requirement for a lot of industries. For example, the HIPAA, PCI, SOC2, if you do the SaaS service. And part of that is really required you have runtime enforcement and runtime DLP, for example, the data visibilities. You want to know, hey, what's the data flowing between the applications at runtime? And you want to be able to, visibility of that, you want to enforce that. So really you need, if you think further ahead, the whole thing, right? You want to have the right to be able to cover all those points for you. Otherwise, you may have to look at multiple solutions, which I really don't think that's easy, because Kubernetes itself is a complicated platform, right? It's really convenient, super easy to use, but at the same time, nothing's free. It's really complicated. And think about the right tool going to help you to basically reduce the hurdle on all those complexities on the security side. That's that's pretty much my thinking about what people should do to cover.
You covered a lot of ground there too, Fei. One of the things that you mentioned was just the source of where so much of this is coming from. It's not just our own code; it's open source too, Brian, as you mentioned. It's images, container images, things that we may have created some time ago, or maybe we're sourcing that differently. It's all through that life cycle. That fits really well, kind of how I'm guessing, Brian, how Sonatype approaches this automation of the build, ship, run model, and where in that chain, if you will, of events, both automation occurs, but also how do you think about security at those different stages? Are there some, thoughts or best practices, ideas that you have from looking at it from that perspective?
Yeah, I think being able to integrate it into many of the places as possible, at least the go, no go type of decision is actually super important for a developer friendly approach, right? So if you move all the way back to, the further left you get, if you start breaking builds, as an example, or blocking downloads, not all vulnerabilities apply to all applications equally. Same thing with like licenses. A GPL might be okay if you're building a service because you're not distributing it, but if you're shipping code, probably not okay. And so one size fits all type of approaches are no good. And so what you often need to be able to do is have something, like a gray list, conditionally approve. And the only way you can do that is if you have more than one go, no go check. So for example, you can, let's say you have a manual approval approach on some of these things. You can allow a developer, you can tell them, well, don't use this thing. It's not going to be approved. It's red. You can use this one. It's good. It's green. Go ahead. But this other one that you're using, okay, it's maybe new. Based on the data we have available, it's probably going to be approved, but it's not yet. So it's yellow, right? So you want to be able to allow that in some cases so that you don't interfere with the development flow, and so that they can get started optimistically. It's sort of an optimistic versus pessimistic lock type of approach. But you can only do that if you have the ability to later follow up and say, you know what, actually we found something, that thing can't be used, it's now red, and you have to back it up. Because if you've only got one gate in place, once you've let the horse out of the barn, so to speak, it's game over, right? So that's one of the lessons we learned early on, and how we manage that, and that extends into containers as well, right? And that reaches it into the runtime aspect, being able to understand what's still out there, how far it went, maybe being able to shut things down if you retroactively find out about a problem that's egregious enough. That's the important part of being able to manage the supply chain. And in other cases, you imagine the continuous security, when you don't have those types of multi go, no go checkpoints. Imagine the build is working, everybody goes home overnight, a new vulnerability is disclosed. You come in the morning, nobody can build. Well, that's not good, right? Because is every developer on your department responsible for fixing the one dependency? Probably not, right? But you just interfered with everybody. First, they're probably all going to be pointing fingers trying to figure out who broke the build because you misdirected against the problem. It's much easier if the build is warned, as an example, and it's very clearly why it's warned, and we'll say something like, warning, we're not going to let you release until you fix this. This is really important, but we're not going to break the build in the meantime. You just can't cut a release. That's what the security people in that instance actually mean. But if you don't have a tool that's designed to think through that problem, you only get the, I'm just going to break the build. And then you make it harder for development to actually fix the problem. And you stop everybody else and you make them upset, and then they unhook the tool and yada, 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 right? So those kinds of things, they seem nuanced, but they are absolutely critical to being able to manage the supply chain in the least disruptive way.
It's interesting. We have Mike asked us another really good question. He was watching the movie The Net recently, and he is inspired by the question. I haven't watched that movie in a while. It's a good one. He was asking, is 2021 going to be the year of a deep fake? Now, we think of deep fake as in videos and images and things like that. And, he's really bringing it up as a, causes, are we going to see things happen where we may be getting fake data, or the source of where we're getting something? You mentioned, Brian, the open source that you're involved in. Is that potentially a big area we're going to see a lot of security concerns of? We used to trust those things because they were trusted, and we just have always trusted them, but maybe not so much anymore.
Yeah, I mean, I feel like the details behind the SolarWinds supply chain attack, as we understand it, it's still an unfolding story, right? But it's hard to imagine what you really mean by deep fake, as in like faking video down to code. But I would say they got pretty close, where they had adapted the code, the malicious code, to use the naming patterns and naming conventions of the rest of the actual legit code. So even developers that are in there just scanning through it, it was hiding in plain sight. Right. So, I mean, that's as close to a deep fake, I think, as you're going to find in this analogy. So the answer is, has it happened? Yeah, it's happened. It's probably happened a lot,
Yeah, it's all happening in different formats, right?
That's right. Yeah.
It's maybe not just identity. Like I hear recently, the people use masks a lot today. You can basically unlock your iPhone with a mask. So that's kind of similar technology, not a technology, but the concept behind that. And it's already happening. That's why we were thinking, right, the security is also complicated. You don't want to have only one point of check. For example, password itself is not enough. The behavior detection behind that is also critical, right? You want to have multiple angles to know, hey, this thing goes crazy, right? This container should never talk to external. Suddenly it talked to external. This container and that pod should never talk before, but they talked suddenly. So those are kind of malicious point of view. You want to know, hey, this behavior detection is combining of multi-vector detection. Then based on that, you can get a good coverage. Similar for Sonatype, right? Intelligence on the license and open source management side. This is something malicious. This is strange. Right, it should not happen. This library never being used. How come it downloaded or put into the build? Those are the alarms, and you should put more attention on. By this way, even though, let's say, password was leaked, maybe people just saw your password from your phone, but still you have another layer of protection at the back end. That's, I think, really where the security is going right now.
Well, I love that you brought up both of you. You brought up behaviors, and you were mentioning the SolarWinds, Brian. One of the things is it's not only just getting in, right, breaking in, getting into the build process. From the write-ups that I've read, there was some very sophisticated thinking that went into how do we avoid detection? How do we not do things like don't kill processes if this isn't the build we want to be involved in and inserting our code into? They would wait things out and put encrypted messages within the logs that they would use to maintain state between what's happening between activities. But to the point around behavior, it was avoiding detection, in a new way, in a new environment. I mean, we think about a production environment, we're avoiding detection from the security team and operations. Well, how do we avoid detection by the developers or the DevOps or the tool people? That's if I guess we made a prediction, that's another element of it, is we need to look at the behaviors across the entire supply chain inside the company. Make sense? Agree, disagree? Feel free to disagree if you don't think that's right.
Agree. And Mike asked to follow up, does this apply to data as well? It's like, yes, it does. How do you solve that? I stay tuned. That's another webinar. Yeah.
We'll go get some data about that. No.
That's the reason we try to, like both Sonatype and NeuVector, trying to collect a lot of information, non-intrusively. But the purpose of that is really you build a good knowledge about the behavior, about the application. Then, as a feedback, you can use that knowledge to intelligently decide something proactively. So that's really trying to, as I said, not catching something known, but trying to catch something unknown. So that's really the advance here we want trying to achieve, right? Advanced technology we try to do is basically trying to do things proactively, right? Not waiting when it's happening.
Yeah, very good point. Well, let's, we have a few minutes left here, and appreciate all the great questions that we've gotten. Mike seems to be on a roll, so we'll invite him to our next webinar we do together. Thank you, Mike. We appreciate it. What do you think are some of the challenges that are currently going maybe unaddressed in the market? Where do you see opportunities for addressing new security issues that might be emerging, or just nobody's come up with a good solution to solving some problems we still have? Either one of you can go first. Take a shot at it.
Yeah. So I think we as engineers, our CEO is fond of saying this, we tend to gravitate towards solving the hardest problem, right? So we spend a lot of time talking about what's new, what's next, what's better, what's the next great thing. I mean, we spent a lot of time here talking about that. The sad reality is so many of the companies that I go in and talk to don't have even the basic practices in place. They couldn't tell you what their actual software bill of materials is for any of their applications, let alone across their entire portfolio. And what's shocking to me is many times those same companies their main day job is producing physical goods that we all as consumers absolutely expect that our food is traceable. And so when there's an outbreak of salmonella, they can figure out, which batch it's from and pull it back. And when our planes have problems and our cars have problems, we're used to getting the recall notices. We expect that. It's not something we even think about. Sometimes those same companies don't do that for their software. And it's kind of shocking to me because it feels like you should know better. I don't need to tell you the analogy. You are the analogy, and the practices just aren't there. Now, of course, with anything, there's a spectrum, but I think that's the sad reality, that we could probably get the problem 80% solved just by doing the things that exist today, the things that have existed for a decade, from my perspective. That's I think the thing that people need to focus on. The bleeding edge is awesome, but it doesn't help if you ignore all of the basic hygiene practices. It's like with the pandemic, washing your hands has always been important, right? Not just because there's an airborne disease. It's still important, maybe not because of the airborne disease, but it will help you be healthier in general, which will help you respond. It's that kind of thinking that is not well implemented across the industry. So that's my plea. Let's raise the bar on the basics, and a lot of these challenges will be solved.
I think that's a really good point. You never want to hear, "Oh, I didn't know we were using that library."
And yet they do on a daily basis.
Like who inserted that into the bill? Yeah. Thank you very much for that.
It reminds me, I saw some real cases, right? When NeuVector was deployed in some production environment, it's like a bank environment, right? And we detect some low version SSL connections still happening a lot, right? People supposedly should already upgrade their OpenSSL library to the newer version, which don't have Heartbleed issues inside. But it's not the truth. We see a lot of cases like
it's that. It's exactly
like
that.
a couple years old containers, a couple years old applications. They just, it's a legacy thing. Nobody want to touch it, right? Otherwise, it's too much trouble, but it's still happening. This is one thing. Another thing I want to add on top is, as I just mentioned a little bit, this Kubernetes, is growing so fast, but itself is really not easy, especially for a lot of companies not doing software, right? Like they were SMB companies, they were not software expertise. That's a big learning curve for them. They were actually still try to understand how this works, still try to migrate their application to container, to distributed system. It's very different. I think that's really the biggest challenge I would say we see so far. It's a lot of companies like it, understand the concept, but when go to real practice, it's still hard. So that's why I think the ecosystem is working together. We're gonna make this more and more easy for you. Like NeuVector's job is make security super easy for you to use. So you don't really need to worry about how should I configure this, configure that, right? I think similar thing for storage network, for example, service mesh. If you compare like 3 years ago, right now Kubernetes itself is already super easy to deploy and use. Right, 3 years ago when I tried to deploy Kubernetes, it's not easy. I mean, take maybe days to figure out which libraries, which components, should be the right one. But now it's just getting better and better. I think that's the another complexity layer on top. Now you are on mute, Mitch.
Sorry there. We were talking about sources of where you're getting things from. Now you can get Kubernetes from many places, right? You can get it from VMware. You can download the source. You can get and there's also Kubernetes as a service that cloud providers might be running. So that's part of that landscape that's getting more.
Well, right? It's changing fast, which is good. But other side, right? How can you follow up with that? It's just keep changing every week, right? So that's another, level of complexity there.
Yeah, we have unfortunately, I don't think we're going to have time to address this. We have a good question from Rudiano about sort of a DevSecOps transformation strategy. Maybe just an opening question of, if you haven't started working on how would we get started down this path? What's a good start point? Brian, do you have any thoughts of, if you have a team like, okay, we really need to get serious about this stuff. You talk about the fundamentals. Might be one good place to start. Are there others?
Every great journey starts one step at a time. Get started. Identify a problem, fix it. Identify the next problem, fix it. I think people get stuck in trying to plan out the entire route ahead of time, and you get into analysis paralysis. DevSecOps is inherently, agile in nature, and so should your transformation strategy be. I think it's really that simple.
Mm-hmm. Don't overthink it. Pick a problem that would really be, we keep having this. Let's fix it, right?
That's right.
Well, Kubernetes, what we see a lot of companies, they start from one single small cluster, start from one application. You gain practice, you're gonna gain experiences on that, then you can scale out. We see a lot of patterns like that. I think, as Brian said, you start from one single application, a small cluster, then you can learn from there and grow from there. That might be the practical way to do it.
Excellent. Well, we're almost at the top of the hour. I want to respect everybody's time. Everybody has another Zoom call waiting after this, right? Or whatever meeting hosting facility that you use. I want to thank both of you gentlemen, Fei Huang and Brian Fox, for a great conversation. And maybe we can pick up on that transformation strategy to DevSecOps on a future episode of this type of roundtable. A couple of housekeeping things. One, I want to let everyone know who our 4 gift card winners are. Let's see. We have Emily R., Otis B., John W., and Rick F. the four of you will reach out. The DevOps.com folks will reach out to you, let you know how to get a hold of those gift cards, maybe pay off a few Christmas bills. Might be still hanging around while you're waiting for your tax return or get that filed. So also just want to mention too, our handouts again, if you haven't downloaded those, we'll attach them. Some super good information, a lot of rich information in those. So please check that out. So Fei, Brian, thank you, gentlemen. It's been a lot of fun. Great time talking with you.
Thanks, everyone. Thanks.
And we want to thank all of our audience for joining us today. Your time's super valuable. An hour of your time, and you've spent it with us. We're honored that you would do that. We hope we've used the time well with you. So we wish you the best. Have a good day, everybody.